This computer, that'll be interesting. Okay. So I am borrowing my daughter's computer. So if somewhere up by the names it says Eliana, just know that it's just my daughter's computer because mine froze. Like literally, I should just shut it or something. My laptop just froze. Um, so let me make a couple of quick announcements, everybody. Okay, this is the last week of class for the spring quarter. So this is week 10. And for the whole campus, everybody in all the classes, this is the last week. Next week is finals week. You can take your final, okay, anytime you're ready. You could take it this week, you could take it this weekend, take it on Monday, but you need to get it done by Tuesday night at midnight, okay? And what I'm going to do to help you prep for the final, since this is our last night of Zoom class, I will send you, I was looking at it earlier this evening. I will send you I made a Jamboard. I'll send it to your school Gmail account, okay, for Everett Community College, that has slide after slide after slide of just review things for the final. And you just have to look at it and follow how I showed you how to get the answers, and it'll be a nice review for the final exam. So, and then let's see. Um, yeah, so if you're missing any assignments, you see some zeros in the grade book, you kind of have until Tuesday night at midnight to try to get everything all into me. And then also, I have 14 students in this class, and most of them are all doing fine. Your next class is TS 70, and we're offering that this summer in a couple of different times, and online option as well. So if you're planning on continuing on, you may take classes this summer, and I'll be teaching this summer, but I'll be teaching 2 English 98 classes and a 60 class, which is what this is. So, um, all right, well, let's jump into things. And we're going to be talking about two main concepts. It's on the screen here: ratios and proportions. Later, I'm going to restart later tomorrow. How's that? Is that going to help me? All right, so ratios and proportions. So, hey, that's better, isn't it? So just as a concept, and you'll see this again, I know in 76, Math 76, but you see how over here on the left, I've got a ratio of 4 to 5. Like sometimes you'll say, in that school, there are 4 girls for every 5 guys, or vice versa. And so they'll spell it out. Just sometimes you'll see it 4 to 5. They're expressing a ratio, or 2 to 3, 2 for every 2 of these. You get this in cooking, and you get this in like mixing bleach. If you've ever done that with something, they'll say 1 cup of bleach for every 1 gallon of water, or 10 cups of water, or something. So that's a ratio. It's a fraction. Okay. Be aware, and please write this down in your notes here, that you've got, see that little, this is called a colon. It's not a semicolon, it's a colon. When you have a number, colon, something on the number, that means that's expressing a ratio, okay? So just be aware of that you'll very often see that as a way of expressing a ratio. And then a third way to do it, you can see over there on the far left on the right a little bit, is to use some kind of a fraction, a ratio of 4 to 5 here. This one right here as a fraction is a ratio, okay? And so you can just kind of be aware of that's a ratio, okay? All right, it just occurs to me that I'm using my daughter's computer. You know what that means? It doesn't have the right software for my pen, so we'll see how this goes here, okay? And then sometimes you'll see it as division form, 4 divided by 5 as a ratio, okay? Just kind of be aware of that can be a way of expressing a ratio. Let's try something a little bit different. Let's just do this. All right, so a couple of ratios. Here's a concept I want you to write down in your notes, this concept of equivalent ratios. Hey, I've got a little pen thing here. I can do this equivalent ratios concept here, okay? And the simplest one that I can think of that kind of makes sense to think about is you all probably know that 1/2, okay, the fraction 1/2 is equal to, okay, it's equivalent to 4, like 2/4, for instance, okay. They are equal because if you reduce 2/4 down, it becomes 1/2, okay. So they're called equivalent ratios, which means they basically equal the same thing, okay. Um, so that's the concept that equivalent ratios are two fractions or two ratios that are equal. We have the example of 4/8. 4 is the ratio of 4 to 8 is equal to the ratio of 16 to 32. Why? Because 4/8 is a half. That's half of 8, right? 16 is a half of 32. So they both are, if you express them, reduced down to their lowest form, they're both a half, okay? So they're equal. All right, we're going to get into a bunch of trying to figure out, okay, 4/8 equals what over x over 32, okay? And I'm just going to say to you right off the bat that this will be challenging for me to, hey, my computer started working. You know what? Let's see what happens here. Sorry, I'm just happened to look because I realized it really would be nice to have my pen. Cancel, does that work? No, it's not working. Okay, sorry about that. Back, I'm back. Um, so, when I look at an example like this one right here, this 4/8 equals x over 32, I can do this kind of in my head by going, okay, 4/8, how did the 8 become a 32? I must have multiplied by 4, right? Times 4. So sometimes you can just do that in your head. You go, okay, I can figure this out. I multiplied it by 4 here. So I'm going to have to multiply the top number by 4, okay, times 4. And that would give me 4 times 4 is 16. Yeah, 16 32s. So that's a way to do it. Or look at the one at the bottom of the page here, okay, this one right here. 4 over x equals 16 over 32. Sometimes you can just think it through, okay, and go, okay, how did the 4 become 16? I must have multiplied by 4. Uh-oh, but this is a little bit weird here. I don't have a number to multiply by 4 here, but I can think with me for a second. What times 4 gives me 32? 8 times 4 gives me 32. So that helps me figure out that x should be 8, okay? If I kind of write it outside the circle here, that x should be 8, okay? So sometimes you can just look at them and kind of like figure out, but other times you won't be able to do that, and that's where I'm gonna wish I had my pen, because we gotta make it into an algebra problem, okay? So we've got the ratio of 5 to 2 equals 10 to what? I would, if you get this in your homework, okay, or you see it on a quiz at the end of the week, this is what I want you to do, okay? I want you to make it a fraction, 5 over 2, and then just go equals, just say that it equals, and then 10's the first ratio, so that's 10 over, okay, and then you can call it x, you can call it whatever you want, b, but you know, I can figure this one out by looking, okay, 5, how did it become 10? 5 times 2 is 10. So I can multiply 2 times 2 and get 4. Okay, you see how I did that? I looked at how did this 5 become the 10 and multiply by 2. So I can do the same to the bottom, multiply by 2. And again, so I've mentioned that before. So that's how I want you to do these. I want you to go ahead and just, make it a fraction. The ratio of 7 over 2 is equal to the ratio of 14 over what, okay? And you can solve for x. That should be an equal sign there. Come on. I'll call it x again, okay? Yeah, so 7 times 2 is 14, so 2 times 2 is 4, okay? So sometimes you can do it in your head like that, okay? I hope you can kind of make sense of that. You can kind of like, look, this became that by multiplying by the same number, so if I do the same to the bottom or to the top, then I will be able to solve it. However, you will run into times where you can't do that, and we're going to get that to that in a moment, okay? So what I would like you to do is I would like you to go ahead and take a moment and copy down what you see on the screen here. And all right, so ratios have two numbers, okay? 1/2, a ratio of 1 to 2. And the word ratio has two syllables, so that might help you remember it. Ratio, two syllables. Proportions, you're dealing with two fractions, okay? So a proportion is a statement that two ratios are equal if you say they're proportional. But when we're dealing with proportions, we're often, for example, 4/5 is equal to 8/10, okay? And again, we're going to express that as, we're going to go ahead and just write it out as a fraction, is equal to 8/10, okay? Um, so, in case you didn't hear me say this at the beginning, my computer is not working at all, so I'm having to kind of, I wonder what happens if I go back to the pen here. Is this going to work? Sort of. It's working for the moment. Okay, to 8/10. Now, here's a word that I want you to put in your notes. Proportions are said to be true, or you'll learn in your other class, like 70 and especially 76, they'll call them proportional. Um, this word here, proportional, if they're equal, okay? So if the two fractions or ratios are equivalent, which means that's like they're really equal if you reduce them, and they're false, sometimes people will call them false if the fractions or ratios are not equivalent, okay? And so they're true if they're equal, okay, or equivalent. This word equivalent has almost the word equal in it here, okay? And they're false if they're not, okay? So that's just something to, little vocabulary there. A true proportion of two different fractions means they're equal, they're proportional, or they call them equivalent. All right. By the way, I'm going to show you a little secret over here real fast on how to figure out if two fractions are equivalent. If you take 1/2, hey, my pen is working, equals, let's say 2/3, okay? And you're trying to figure out, are these two fractions equal? Here's a little trick. If you cross multiply, 2 times 2 is 4, 3 times 1 is 3, okay? If you get different answers, that means it's a false proportion or it's not equivalent, okay? If you get the same answer when you cross multiply, then that means they're equal proportions. So look at this, 1/2, for instance, or does it equal 2/4? Well, we talked about that. Yeah, everybody knows that 2/4 is a half. Look what happens if I cross multiply. Okay, that's a 2 there. 2 times 2 is 4, 1 times 4 is 4. Hey, that means that this proportion here is true. They're equal, okay? And you can find out on way bigger numbers. If you had, like 17 over 34, is that equivalent to 54? Oh my word. So that's kind of interesting. By the way, that's my daughter. Remind me later. Did you see my daughter there? She does ballet. Can you guys still hear me? Let's see. I am having lots of fun here tonight. I'm sorry, guys. It is what it is. Okay. It made my whole thing go away. Everett Community College. I'll be back in a moment, guys. Hang on there for me. Week 10, this one's one we're right here. Okay. Looks like I'm gonna have to write on it. Okay, I'm back. Sorry. Let's see. I think we were about here, right here. Okay. All right. So anyway, in this example here, again, I could do this by just eyeing number 1 here. Okay, I could just eye it and kind of figure it out. I could go, oh yeah, 5 times 3 is 15, so 3 times 3 is 9. All right. Now what I want to show you though is, remember last week we started doing one-step algebra equations. We're solving one-step equations. Here's what you're going to do to solve these. You're going to start getting used to cross multiplying and taking the two ratios and put it into an algebra problem. Okay, so we're going to do that by cross multiplying. So watch what I do to number one. Please write this down. 3/5 equals n. That's my variable, okay? My unknown over 15. So 5 times n is 5n. So 5n equals, and then 3 times 15 is 45, okay? Now see how long my pen decides to cooperate, okay? That is now an algebraic problem that we kind of learned how to solve last week. We learned that whatever's going on the side of the variable, the n, we can get rid of the number by doing the opposite operation. You know, like if it was 5 plus n, then or n plus 5, if we subtracted 5 from that side, we'd have n by itself. And then we'd have to subtract 5 from the other side, because whatever we do to one, we have to do the other side of the equal sign. In this case, it's multiplication. So if I divide, that's the opposite operation. If I divide this side by 5, and then therefore I got to divide this side by 5, okay? That will, I'm going to choose a quick different color pen here, that will cancel out the 5s and give me n equals 5 times 9 is 45, 9, okay? N equals 9, okay? Let's do one more. Okay, let's do another one here. Let's look at number 2 here on the screen here. I have 5/8 equals 25 over m. Well, 5 times 5 is 25, so 5 times 8 would be 40. I suppose I could do it in my head. But I'd like you at this point just practice doing it the way I just did it above, okay? I'm going to cross multiply 5m. I'm going to put that equals 5m equals, I know that 25 times 4 is 100, and I got times 8, so that's going to be 200. Just kind of showing you how I did that math in my head there. 5m equals 200, okay? All right, the operation going on the side of the variable, the letter, okay, is multiplication. That's 5 times m. When they're side by side like this, there's not a plus or a minus sign. When they're right next to each other, that means they're multiplied. It's 5m. There's 5 m's. So let's say it was 2. M was 2. That's 5 times 2. That'd be 10. Okay. It's multiplication going on. How do we get rid of it? We do the opposite operation, which is just like we did above. We're dividing the same thing coincidentally. So we got to do the same thing to the other side. Why does this seem kind of weird here to read? All right, that is going to cancel out my 5s and leave me with m equals, I know that 5 goes into 100 20 times. So 5 must go into 240 times. Just kind of doing the math real quickly in my head there. Okay? All right, let's kind of continue on, kind of showing you. Let me give you a moment to finish copying that. We're solving for the missing letter, okay? We're kind of taking what we learned last week, how to do, they gave you the problem, like 5n equals 45, and then you had to solve for n. Now you're looking at two ratios and trying to solve for that missing letter by algebraically, okay? All right, let me see here. Let's just do at least one more of this type, at least one, okay? We'll call this number problem number 1 here. I'm really happy that I'm surprised this pen's working. We'll see how long it lasts. So I've got to solve for 9 times what? 6 is 54. 9 times 5 is 4. So I could multiply 6 times the top number and just do it in my head. 6 times 4 is 24. I could do it like that. But once again, we're having you practice doing it algebraically with one-step algebra. 9r, so I cross multiply, 9r equals, okay, I'm going to take my little calculator here, and really fast I'm going to multiply that. What do we have? 4 times 54. 54 times 4 gives me 216, okay? 216. Okay. Now, same operation. I've got multiplication going on the side of the letter, the variable. So the way to get rid of multiplication is to do the opposite operation, which is in this case to divide by 9. So I'm going to divide this side by 9. That cancels out the 9s. It becomes 1, which is just the same as 1r or just r, okay? That leaves me r equals, and if I take my calculator divided by 9, I get 24, okay? All right, I hope you're kind of starting to get this, okay? What I'm gonna do now is for a couple of them, I'm just gonna set it up. Not even gonna finish the problem. I've got 5 over 3 equals b over 15, okay? All right, so I'm gonna go 3b equals 15 times 5. Well, 15 times 3 is 45. I should know this. What is that? Clear, sorry. 1 5 times 5 equals 75. Yep, there we go. 3b, this is a b here, okay, equals 75. And then again, I would divide both sides by 3. We'll call this problem number 2. Let's just do one more on this slide, okay? And I knew it wasn't going to be long before I started losing my pen here. 3. All right, so I'm going to have 10c equals 200 equals 270. How did I do that so fast? I multiply 3 times 9 is 27, and I added the 0. Okay? Divide each side by 10, and you'll get 27. This is so easy that I just can't resist. 10 goes into it, that cancels. I get c equals 27. Okay? All right. I hope you got the idea. Okay? That's what you're going to have a bunch of homework doing that concept. And let's look at a couple of story problems. I want to show you how to set them up. Okay? Because you'll see some of that in your homework and maybe on the quiz as well at the end of the week. So example 1, a recipe calls for 4 eggs in a cake to serve 9 people. All right, I want you to see that this is a ratio. You need, for every 4 eggs, it's enough to serve 9 people in whatever we're making here, baking or cooking. That's a ratio of 4 eggs to 9 people, okay? So what I do is first, I just write down the ratio here. 4 eggs to 9 people, okay? That's the first ratio here. So if I kind of like draw an arrow, so you're really clear where that came from, and I'm just gonna draw an arrow here, just to let you know. Okay, then it says, how many eggs will be needed for a wedding cake for 270 people? Okay, so watch what I'm doing. I'm calling this N eggs, because they're asking how many. And then I've got, it says this is for 270 people, okay? Notice that I've got my people and my people side by side here, okay, right next to each other. I'm keeping them together here, okay, people and people here. And I got my eggs and my eggs side by side here, keeping them in the ratios so it's consistent, okay? Then I'm ready to just, okay, am I ready to solve my problem now? Yep, I won't do the whole thing, but I'm definitely ready now. I can go, this whole ratio equals 9n, I hope you're following me, 9 times n equals 270 times 4, which is 270 times 4 is 1080, okay, equals 1080. And then you would just divide both sides by 9 to solve the equation, okay? Just divide both sides by 9, and you're going to get n equals, and punch it in your calculator, and you'll get it. I'm just going to do it real fast, okay? Because it occurs to me it'll only take me a second. N equals 120. So here's what the answer is, okay? It says, how many eggs will be needed to serve a wedding cake for 270 people? 120 eggs, by the way. If you're thinking what I'm thinking right now, that's a lot of eggs, okay? How many eggs will it take? It's going to take 120 eggs, okay, to solve that. So do you see what I did? They gave me a ratio, and then I set it up. I kept eggs side by side and people side by side. Solve for n, okay? Let's look at least 1 or 2 more, okay? I can give you a minute. It's a couple seconds to finish copying that. All right. Let's go ahead and take a look at the next one. All right, we got a ratio. It says the ratio of number of jelly beans to jawbreakers. By the way, whatever they give first, that's going to be your first number. Jelly beans to jawbreakers. Okay, so this is like that little colon here. We got you got jelly beans. Okay, call these J beans. No, and this is jawbreakers. Okay, J breakers. BREAK. Okay. That's the second ratio there, okay? Losing my pen here. Okay. So jelly beans to the ratio of jelly beans to jawbreakers is 9 to 15. So watch how I do this. I got 9 to 15. I'm going to be really clear though. I'm going to just call this one jelly, 9 of these jelly beans. And I'll just say jelly bee. And I've got 15 of the jaw bee. See how I'm just being really clear? Okay. Equals, okay. It says if there are 36 jelly beans, okay, I'm going to keep my jelly beans side by side here, okay. I got 36 of these jelly beans, jelly bee, okay. I got 36 of these guys. How many, they want to know what number of jawbreakers, okay. So you can call it A, you can call it X, you can call it whatever you want, but we're solving for this, okay? So I'll call it A, okay? Okay, you see how I set that up? I've kept everything side by side. At this point, we're just ready to kind of roll here. We can go 9A. I'll just put this whole ratio proportion here. If I turn it to an algebra problem, is 9A equals 36 times 15, which is 36 times 15 is 540, okay? And I think from here, you know what to do. You know that you can divide both sides by 9, and you got it. All right, a desk. On a desk, the ratio of pencils to crayons, I've got pencils to crayons is 8 to 6, okay? So I'm going to pick a brighter color here. We've got a ratio of 8 pencils to 6 crayons. I'll put C here and P here, okay? Equals, if there are 28 pencils, so I'm going to keep my pencils side by side, that equals 28 pencils. They want to know how many crayons are there. So we'll call this C, okay, for crayons, okay? How many C? 8C equals 28 times 6. You go from there, okay? All right, let's see if I think I just have, this is like my last slide, I think, yeah. I'll just show you this example in case you run into this in your homework, which I think you might have something like it. Hernandez leads the baseball league with a batting average of 425, okay? He struck out 2 times for every 6 times he went to bat. So 2, okay, SOs, these are the strikeouts, okay? For every 6 at-bats. I don't know if you're a baseball fan, but you probably would recognize all this a lot in this language, at-bats, okay? Equals, okay, if you went to bat 600 times, keeping this all proportional side by side, 600 at-bats, says he went to bat 600 times, okay? So that's why I put this here. How many times did he strike out? They want to know X, so they want to know strikeouts, okay? So I'm going to have, I'm going to have 6X equals 2 times 600 is 1200, okay? 1200. And then I'm going to have X, both sides divided by 6. And I'm going to have X equals, I should be able to do this in my head, but 1, 2, 0, 0 divided by 6 is 200, okay? 200. So this is what it means. How many times did he strike out? Okay, if he has 600 bats, 200 strikeouts. Okay, just if I wanted to really impress my teacher that I really know what I'm talking about when I found my answer. Okay, I found out that he struck out 200 times. That's a lot of times striking out. Okay, and that is the concept. Okay, those are the kind of the main concepts. So in review, okay, just to kind of encapsulate all this, what did I teach you tonight? I taught you real quickly, I taught you the idea of that there's something called um, a ratio. Like it can be expressed as 5 to 4 here. It can be expressed as 5:4 here. That means ratio. It can be expressed as a fraction, which we just got through doing a lot of, or sometimes they'll write 4 divided by 5. But in all cases, it's read as a ratio. Okay. Um, and then we started talking about what's an equivalent ratio. Okay, this concept of equivalent ratio means they are ratios that like 1/2 equals 2/4 that are equal. 4/8 is the same as, okay, 16/32. Okay, they're equivalent, they're equal. And that's what equivalent means. And then we practice solving some, okay? Some of them you can just look at and do in your head, figure them out. Um, we also talk about proportions, okay? Things are a proportion. They call it a true proportion if those two fractions side by side, one on the left, one on the right, if they're equal, okay? If you cross multiply and get the same answer, that means that it's a true proportion. You got 4 numbers, you got 2 fractions. If I cross multiply and I get the same answer, they're equal. If I'm off by just 1, and if I don't get the same exact answer, they're not proportional. So in the language they use, they said, hey, a true proportion or a true ratio here is where you get the same answer, and a false one is where you get different answers, okay? So we talked about that. And then we also talked about a whole bunch of this. Let's take these proportions, 3 to 5 equals what to 15. Let's put it in an algebraic one-step equation and solve, okay? And so really, we're spending quite a bit of time kind of re-practicing those one-step equations. And as you can see, we just did a whole bunch of that. And then we looked at a couple story problems, okay? All right, last announcement or two before I turn off my recording here. I mentioned it at the beginning. I will send you, I probably should do this. Let's see, I'll do it tonight, okay? I will send you the Jamboard. This whole thing, this slideshow here is called a Jamboard, okay? That prepares you for the final exam. It's like it goes through the kinds of problems and questions you'll see. And you'll see my work right here like I did here. You'll see how I solved each one. So that's all there for you to use as kind of a prep for your final, okay? Additionally, I will send you this slideshow tonight. And then I will send you the recording as well so that you can watch it. And I apologize that my pen went crazy and I had to use a different computer. But hey, things turned out better than I thought they were going to. So